welcome to this video. We're going to see how to calculate the moment of inertia of a hollow cylinder. So imagine you have just a cylindrical tube, okay? Then we're going to see how to calculate its moment of inertia. So the idea, as usual, is really easy. If you have been following the other calculations of moment of inertia I did earlier, then you know that the idea is just to try to select an element. Usually that can enable us to generate the symmetry of the whole solid figure we are dealing with. And then you use integration to just sweep out through the whole length or area or volume of your distribution. So in this case, we have this element, which is a ring, okay? Now, if you cut a very thin slice of a tube, of a cylindrical tube, you just get a ring. So in this case, we have a ring, and we saw in an earlier video that the moment of inertia of a ring about the z-axis, okay, which is the main axis of the ring, is mr squared. So you can just, I will leave the link somewhere here, so you can go and watch this, how to derive that of the ring, if you're interested in that. So already we can set sigma as the mass per unit area, okay, the uniform mass distribution. So the mass of the cylinder is m, and its area, okay, its area is it's pi radius L. So this is the surface area of a cylinder. Then we can also set this to dm, okay, which is the mass of the ring, all over its area. The area of the ring is just pi radius dz. So you can get the expression of dm directly. So that's just going to be m on L dz. We okay? So then the moment of inertia of the cylinder about the z-axis is just going to be the integral, okay, of the moment of inertia of the rings, of the elements. And the moment of inertia of a ring is this. So we just apply that formula. We have r, which in this case is the radius, capital R, and the mass dm. And then we integrate over the entire mass range. So this simplifies to r squared m on L dz. Okay? And then z has to go from 0, so this point, to L in order to generate the whole surface of the cylinder. So that's 0 to L. So we can integrate that. It's pretty easy. So that just integral of dz, okay, from 0 to L, so that's just L, okay. And if we simplify that, we get mr squared. So the moment of inertia of a hollow cylinder about an axis passing through the center and perpendicular to the cylinder is mr squared. So yeah, this is really easy and very straightforward. Okay, hope that's clear. If you have any questions, feel free to ask them in the comments, or if you have any remarks, feel free to point them in the comments, and see you in the next video.